Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. Everyone, welcome into the program. Today on the show, we have the one, the only Mr. Ralph Bond. It is Friday. You know what that means. It means pizza day. Well, at least it is for our family. But everyone, it also means that Ralph Bond will be joining us to talk all about science and technology trends, cutting edge, medical research, cutting edge green energy, cutting edge space and exploration. I mean, he really picks fun stories, ones that you might not have heard or might have missed in the week. And hey, we love having this time to kind of catch up and, just relax before a good weekend. So everyone, computeramerica.com. It is up, it is running, and it is there for you if you want to find anything, including past shows, future shows, show notes, articles, reviews, topics, podcasts, of course, and social media links. Give us a like, give us a follow, and there you can follow everything that we do. And also, we'll have the show notes. Those are super important. Highlight those because that will have everything that we talk about. And yeah, I highly encourage you to check that out if you want to read more in depth. But we'll have Ralph on in just a minute to talk about the show notes, talk about just everything. And hey, why don't we go ahead and just bring him on. So everyone, once again, he is our science and technology correspondent for Computer America, and of course does some work over at KEX as well, just bringing fascinating news and science articles to the masses, and we appreciate his time here. Ralph, welcome back onto the program. How you doing?
Hey, Ben, great to be back. And boy, do we have some great stories this week, starting off with two amazing medical science blockbusters.
Yeah, these are going to be really big. And again, if you've heard about it, then good news. You're getting a recap. If you haven't, this is going to be great for you. So, Ralph, let's introduce the folks to you. What do you try to do with your segment here on the show?
Yeah, here we go. So, I'm an aggregator of science and tech news features I find by monitoring a host of online news outlets. And I look for important and sometimes wild and wacky and out there stuff that definitely doesn't capture mainstream press attention. Some does, but a lot doesn't. And I'm always on the lookout for news that gives a glimpse into where we're headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, all over the map, you name it. And need more coffee. And what I do with each news item is present the essential points and in, I hope, a digestible form. And I stress to our audience what you were saying too is come to computeramerica.com, get the show notes for today's episode because it'll have links and pictures, because what Ben and I are going to do is just give you the Reader's Digest highest points, kind of biggest picture commentary. But if you want to dig into the science or the technology in greater depth, you need the links. They'll take you to the articles and sometimes several articles that I use to research a given story. So be sure to check out those show notes.
Absolutely. And of course, if you're watching the video portion, you can see them up there as well, where we'll be playing videos and things like that. I need coffee too. Everyone, Ralph, I think we just jump right into story number one. You're right. Both of us take a drink coffee. Story number one. And this is something that we touched on last week. If everyone's familiar with, this is going to get into CRISPR, but this is something I had not heard of about before, what they're doing with it. So very, very cool.
Yeah, in fact, real quick, the first two stories today are medical science technology related. And it kind of blows my mind. They definitely flew under the radar of the mainstream press because I think you'll agree after we go through them, they're pretty darn profound. But first one up here, genetic heart conditions could be cured with a single shot in the arm, a single injection. What? This just sounds like fantasy. Got this from the United Kingdom's The Guardian and also picked up some more coverage in Sky News, and it was covered elsewhere as well, of course. But let's set the stage here. Genetic defects are the cause of half of all heart transplants and are the leading cause of heart death in young people. So, yikes. But with that dour note, here's the uplifting part. And that's something Ben and I try to do each week is give you an uplifting start to your weekend with positive news. So here's the good news. Funded by a huge grant from the British Heart Foundation, a team of experts from the United Kingdom, United States, and Singapore. What a fun collaboration that is, right? Recently announced that they are working to create the world's first gene therapy cure for genetic heart conditions. Profound. Okay. So, and what's really amazing, Ben, is that this genetic cure would be administered, as we mentioned at the outset here, with a single injection in the arm. And the aim of the research is to cure genetic heart conditions by using precision genetic editing techniques called base and prime editing. And we're going to explain that in a moment here. So to do these genetic editing techniques called base and prime editing in the heart for the first time to permanently correct or silence mutant genes that cause these heart problems. And as Ben teased earlier, this all has to do with CRISPR and things related to CRISPR. And let's do a little quick refresh on this, and then also bring in the topic of base editing and prime editing, because that was a little bit new for me too. So a refresh here. CRISPR is short for, I love this acronym, clustered regularly interspaced short palindromic repeat. Okay.
Of course.
It's a bit of DNA that scientists first noticed in the immune system of bacteria. How obscure is that? Immune system of bacteria. Okay. And that inspired the gene editing technique that everyone now calls CRISPR. And I've got links in the show notes here. You can learn more about that if you wish. And then the news announcement from this group, this team of researchers, talked about using base and prime editing. So that caused me to go out and look and see, I guess, try to get a very quick definition of both of these things. So CRISPR base editing seamlessly changes a single DNA letter, the simplest of all edits, may be all that's required to repair mutations that cause thousands of inherited disease. So that's base editing. Again, just seamlessly changing a single DNA letter. Well, what is prime editing? Prime editing is a potentially significant update to CRISPR gene editing. Prime editing, serves as a search and replace. Ooh, let that sink in. Prime editing serves as a search and replace editor for the human genome. Using prime editing, it is possible to directly write new genetic information into a specific DNA site. Yeah, that's what these guys are using. Used to edit human cells through targeted insertions and deletions to efficiently correct the primary genetic causes of things like sickle cell disease and Tay-Sachs disease. And in this case, this team of researchers are going to apply this to genetic heart conditions. Wow. So in summary here on this story, the announcement made recently didn't really give a lot of scientific details, rather, about how this is actually literally going to work. So not much was disclosed. But so far in the animal studies, the team claims they've already shown that this genetic editing techniques, the combination of base and prime CRISPR, works. And they plan to have human clinical trials sometime in the next 5 years. So we'll have to watch this and see if this works out. But this could be a huge, giant breakthrough if it all comes together and works.
Right. It's and all this gene stuff, I just Googled it myself in all fairness, but the reason why this kind of stuff takes so long, even though it seems like CRISPR is able to make these edits and do things so quickly, Ralph, according to a quick Google search, CRISPR by and large is pretty permanent. You know, some things I read said it lasted 10 to 20 years. Other things I read said that it would last permanently in the body. So if you're permanently editing a person's genes, you want to be darn sure that, you are targeting the correct genes and you're not causing something even worse to happen.
Yes.
So, but I mean, that's also good. It's not like every 6 months you have to go in for a new CRISPR treatment. It's one and done, and you can cure things like heart disease, and that's really, really incredible. And And the fact that, again, whenever you think about heart disease, I think, Ralph, in the past we've talked about, 3D printing organs and growing human transplant organs in solutions and things like that. This is something completely different. Leave the heart, but cure it with a simple stick of the needle. That is incredible. And in your arm, not even in your heart. This is really, really cool.
I know. So. Yeah. Isn't that something? And again, that's the part that I wish they had disclosed more about. Okay, I get this injection. What's the sequence of events that delivers this solution to the heart? That's the part that I didn't find information on, and I'm hoping over time they'll disclose more, or perhaps we can find some better resources as well. So very fascinating stuff.
Right. Yeah. And from my understanding, CRISPR, think of it like a zipper, but a very, very specific zipper, because, DNA is a double helix and that whole thing. It will only fit into certain parts of your DNA, and it will only fit into the parts of your heart or your heart tissue that the DNA will, kind of seek out, and then it will bond to. How it actually gets to the heart and all that kind of thing, that's way above my pay grade. But from my understanding, the body will eventually carry it to where it needs to go.
It's a good analogy. Might be too, like you're injecting into the arm a series of puzzle pieces.
Yes.
With a unique pattern, if you want to say that. And so your point's well made. Even though it's dispersed throughout the whole body through the bloodstream, ultimately it's going to get to the heart, and it goes, oh, I found where I'm supposed to be.
Exactly.
Click,
it will only fit there. Yes, exactly. And hopefully it'll fit correctly and solve so much. So CRISPR, that might have been one of the biggest underrated science stories of like the 21st century so far, but it is going to cure a lot, and a lot of people are going to be better off for it. So
And Ben, I think we mentioned this to each other last time too, as well. When CRISPR came up as a topic, I am seeing just this tidal wave of research announcements relating to CRISPR, genetic editing, and so forth. We mentioned this last week, and it's really remarkable. I think we said also last week that artificial intelligence dominated the news waves, if you will, of the technology community for so long, and now it seems like genetic editing is just suddenly bursting out of the gates and applying itself all over different areas. And so it's very exciting to see this development and trend.
Yeah, and that really has to go with what the science community, I think, kind of does best, is that the people who discovered CRISPR back in like the mid 2010s, they didn't patent it. They released their research, and they were letting everyone all over the world from, like this article highlighted, France, Singapore, UK, so on and so forth. Everyone can use it, and that's why you're going to see all this research, Ralph, is that it's a great, amazing tool that can do so much, and everyone has access to it. It's not like Harvard Medical School is the only one that can patent it.
Right.
So very good on all of them. And really, story number one is a great example, and then story number two, yet again, another example of just where medical technology can make people safer, happier, healthier, and in my opinion, free up your schedule, because all these boosters that we're getting, and yes, you should go get the boosters, but man, they're coming out with every 6 months or something like that. They have a new booster that's coming out for, and just coronavirus, but of course there's other boosters, but story number two, hey, may free up your calendar a little bit. So let's talk about that.
Yeah. Earlier, you just said a phrase, one and done. That really applies to this story. Here's the headline. MIT, good old MIT. My gosh, the range of their research is mind-boggling. Anyway, MIT is using microparticles to create self-boosting vaccines. Wow. Okay. So, as we all know, most vaccines, from measles to COVID-19, of course, require a series of multiple shots to be fully vaccinated. We all know that now, especially in the era of COVID-19. So researchers at the Massachusetts Institute of Technology recently announced that they've developed a one-shot vaccine alternative. This profound medical technology advancement involves using injected microparticles, we'll explain what that is in a moment, that can be tuned to deliver their vaccine payload at different time points, effectively offering self-boosting vaccines. And Ben, this is just, to me, incredibly fascinating. So here's how it works. The microparticles, which resemble, picture in your mind, tiny microscopic coffee cup like little containers sealed with a lid. Okay. I mean, this is a very simplistic visualization. They're
right.
made of a porous, biocompatible material. So porous, that's key. Biocompatible means that your body can accept this material. We'll explain that too more. The microparticles loaded with the vaccine are injected under the skin and can be designed to release their contents at different time points, as mentioned a moment ago. And the microparticles, this is the genius part of it, the microparticles remain under the skin until the vaccine is fully released and boosted. So all the time sequences have finished their course. And then they break down, they dissolve like dissolvable sutures. They just get absorbed into the body. That's the biocompatibility we mentioned before. Wow. So step back and just say to yourself, what are the implications of this? It's absolutely amazing. You can think of so many things. For example, this could be a game changer for vaccinations in regions where people don't have frequent access to medical care. Now, I do want to do one kind of reality check timeout. We talked about it would be lovely if I could get one COVID vaccine injection, right, and it runs its course with the time release thing. So maybe 6 months later, the little microparticles release the dosage I need to be boosted. That's great. The only part that this doesn't solve, it's a marvelous step forward, but the one thing it doesn't address is what we're going through right now. Oh, there's a new variant of COVID-19, so we got to tweak the vaccine a little bit. So it's not an absolute airtight total solution, but what a step ahead for maybe more measles or other vaccines that are so well known that we just know that we need to do this shot, and then 6 months later we need this. COVID might be a little different ball game here, but still, what an amazing advancement. And MIT, they're not just robots. They're not just electronics. Oh no, they're all over the place. And that's the thing that just continues to blow my mind about MIT.
for sure. And to your point with like the first COVID shot where, you needed it 3 or 6 months later, whatever it was.
Yeah.
After you got the first one, you could imagine that, and especially places I could expect in rural places like in rural Africa or, places without the infrastructure for these kinds of things where, Ralph, you heard this with one of the big problems with like the COVID vaccine early on was that the vaccine needed to be refrigerated. So, it's not even like they don't have hospitals. Right. It's like they don't have reliable refrigeration. And it was tough doing that. So you could, one could assume that if you could get one injection and essentially get 2 doses of a vaccine in, that cuts your cost of getting the vaccine out, shipping and manpower, cuts it in half, and that's amazing. Yeah, that's a great point about the refrigeration bit and how this could help in such situations like that. And hey, you know what? Better to get a dose and a boost than nothing, right? And if this can bring this to parts of the world that otherwise would be underserved or not served at all, profound breakthrough. Huge. So that's perfect. And I'm just looking forward to all of these medical advancements that you keep talking about, because what I like about a lot of these, Ralph, is that we talk about them 6 months, a year goes by, and the medical world's not very glamorous. People, there's not big billboards on, skyscraper saying, "Congratulations, the new version of vaccines are here." Like, no, like they just start happening, and genetically modified food and better medical technology helps us all, even though we don't hear about it in the news every single day. So there's that's the uplifting part, is that stuff's getting better. You just may not hear about it, except for here. So there you go. Story number 2. Story number 3. And let's talk about jets. And this thing looks a bit, what old is new, I guess. And essentially propellers for jets. What is this? And picking up on your theme, I kind of thought to myself, this is sort of a Back to the Future story. So let's explain what we're talking about. Headline here: new experimental open fan
jet engine in development. Now, if you're lucky enough to be looking at our video and you can see the images of the illustration of what this engine looks like, you'll immediately catch on to the Back to the Future joke. Right. Anyway, got this from CNN and also a really interesting outlet called simpleflying.com. So I kind of dug around. And also, I think I went and looked at Wikipedia and a couple other places as well. Got a couple of videos for you, too, to take a look at, which is really fun. But here's the story. Late last month at the Airbus and CFM International Air Show held in England, researchers with GE Aviation and Safran, that's SAFRAN, announced plans to use a huge Airbus A380, which, by the way, is currently the world's largest passenger jet, to demonstrate a remarkable open fan hybrid electric engine, which could help cut carbon emissions by 20%, meaning it's 20% less emissions than a standard jet engine. Okay. And again, I want to stress that what the GE Aviation and Safran team announced is our plans. They haven't done it yet. They are planning to do this test. So the experimental engine, as we were alluding to me looks like a super sleek, geeky, weird, but fun in a cool way, stylish version of an old school propeller engine. But you can immediately see some things that are quite different. And it's quite a humorous little video you're showing right now. It's very comical. You should watch it separately with the audio. It's quite good. Gotcha. So the engine features an open rotating set of 12 short twisted propeller fan blades in the front of the engine and a set of counter rotating blades behind the front propellers. Now, the video brings up the whole subject of how this has to do with warm and cool air mixtures. And there's all kinds of aviation engineering geek out. You can geek out till the cows come home on this one if you want to. So dig into those articles. We're not going to go into that depth, as I mentioned before here in the next lineup of notes. But in the simplest terms, the front twisted rotating blades pull air back with the rear blades manipulating the thrust airflow generated by the front set. So it's this kind of dance between counter rotation. And it's remarkable. So for a great and detailed explanation, check out the second video link provided here in the notes. That's the funny one where the guy was dancing around in a ballerina outfit.
Yes.
And as I said before, there's so much more to the story if you want to geek out on aviation stuff. Now, qualifier though, and this was very interesting to me on some other sources I learned about this. This is not the first such engine in aviation history. So we're not saying this is the first ever. What it is the latest cutting edge version of what is called a prop fan or open rotor engine. And I'm going to segue for a moment from some of the reading I did. Back in the oil crisis of the 1970s, and I'm old enough to vividly remember that, the aviation industry, when there was this terrible shortage of petroleum, and to make kerosene the key ingredient of jet fuel, blah, 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 blah. They started revisiting this idea of, can we get a more fuel efficient engine? And they started playing around with this open fan, open rotor, prop fan kind of concept. And then when the oil issue was, I guess you could say, resolved and not a financial burden, they went back. They stayed with their traditional jet engines is what I'm trying to say. So it's got a long history. It actually has quite a long history, but this again is the latest cutting edge version. And because of climate change, carbon emissions, and fuel costs now, all of these things coming to the forefront, the aviation industry is seriously looking at it. When you have GE involved with this, you know it's serious. So the design is intended to offer the speed and performance of a standard turbo fan jet engine, the kind you see on a commercial aircraft today, with the fuel economy of a turboprop. And in addition to producing far less carbon emissions than today's jet engines, the GE Aviation and Safran development team claims it offers reduced mechanical complexity, weight, and noise. And a lot of the articles I read about this, Ben, talk about this will be if this is deployed, if it's successful and it's widely deployed and the next generation of planes take over with the old ones, it'll be a much more pleasant passenger experience because the noise in the cabin will be greatly reduced, which I thought was really kind of neat. Now, the team says the new technology could be ready by the mid-2030s. So we're not talking about tomorrow. This is like a 10-year span we're looking at. So talk about a trend. And would be first used for single-aisle aircraft the type like an Airbus A320 or a Boeing 737. And I thought to myself, well, what's taken so long? You've got this prototype engine. It's all the approvals, all the government, international government aviation approvals, and on and on and on. And the time it takes to cycle in something into the manufacturing pipeline. So there's reasons why it's a 10-year span. Yeah.
Yeah. And I can imagine that a lot of the, a lot of the airplane orders, it's a big deal when they get canceled because they order them like 10 years in advance, whenever people order from Boeing, because those planes, Ralph, I think that like most of the planes being used nowadays are still from like the 90s. Like they're just now cycling out the ones from the 80s. These planes fly for decades. So whatever they put in 2030, you're probably still going to be using in 2040, 2050 as well. So long life planes. Very, very cool. And the design is something, looks so weird, but I'm guessing a lot of computer modeling, and the second video that kind of showed the engineering that went into it. Honestly, they're not going to space, but it looked exactly like the research lab at NASA that I was fortunate enough to go see in Houston.
Cool!
It looked just like that same setup. So a lot of engineering, and hopefully, fingers crossed, it gets here sooner than 2030.
Yes.
Much to your point, back in the 70s with the oil crisis, necessity is the mother of invention. And you know what? If airlines have to reduce emissions, they can speed this up. They can speed up this time.
Oh, yeah.
So,
well, and another thing to ask yourself is, could you take an existing aircraft and retrofit it with this engine? And since it's electric hybrid, as I found in one reference, is that a possibility? Could that be done? And if yes, then wow. A lot more application there if you could retrofit as well. So, but until we see that, story number 3, story number 4, we're just going to go ahead and jump and just talk. I wonder why it was on the brain. NASA is, and I just came up with the title for today's show. And this is the part of the title that is water hunting moonbots. So story number 4. Yes. Yeah. And along with genetics being such a big deal, wow, have I seen a lot of movement, not only, of course, NASA, but around the world, the Chinese, everybody else. It seems like the moon, and getting a moon base and all this sort of thing is, we've seen a pattern in just the coverage you and I have been doing over the last, say, 6 to 8 months. But here's the headline here in this case. NASA is developing a water hunting rover to support moon bases. And I got this. First, I picked this up on slashgear.com, and then I went to NASA's website to get more in-depth information. And if you're looking at the show notes, the illustration of this little guy, the artist's rendering of this thing, if you're a Star Wars geek, I did a little research on the different droids in Star Wars world. And I think there's a little tiny droid that scoots around on the floor of the hangars for the resistance and so forth. Yeah. It's called, I think, a chopper. I think that's so it's kind of this slightly inclined pyramidal shaped little droid, but it's very small. Well, this looks like a big scale version of a chopper to me. Anyhow, here's the story. So of course, goes without saying, one of the greatest challenges for supporting a long-term moon base is securing a water supply, of course. Recent research, and it goes back to 2018, has found that there is water on the moon, especially in the form of ice in craters around the South Pole. That's kind of cool. And to locate this water, NASA is developing its Viper, VIPER rover, which to me looks like a droid, as I mentioned, right out of a Star Wars movie. Now, Viper, of course, it stands for something. Stands for Volatiles Investigating Polar Exploration Rover. This will someday be sent to, you got to have an acronym, will someday be sent to search around the moon's South Pole, hunting for craters, hunting through craters for evidence of ice there. And because of the dust covering the moon called regolith, and we've talked about this before in other rover-related stories, the rovers, you're going to love this part. I think this is really great, and that's what the other image on the show notes is referring to. The rover's wheels and suspension system are being designed to handle traveling over and through craters. Yeah, that video is really good you're showing right now. Should it encounter extremely fluffy soil, Viper can lift each of its wheels independently almost like marching feet. Get that visual, and use them to dig into and sweep along the surface. So the video you're watching right now is a perfect example of what, and you can see how soft the material is they're having it go through.
Yeah, viper kind of takes on another meaning because it reminds me a lot of like an undulating snake kind of going through sand.
Good one.
It kind of twists itself to kind of snake through the sand. It's very cool.
Yeah. It kind of reminds me here on Earth. I saw a TV commercial last night, and it made me think of this story. I think it's Dodge Ram truck. I think that's the company. And they have this little thing where there are all these little crabs, a crab walking across a busy street or something like this. And then they show the truck, and the truck has the ability to manipulate its wheels so that you can parallel park or do different maneuvers, unlike any other kind of vehicle. And it reminded me of this sort of a technology for the
GMC
Viper
Hummer
Rover.
EV can crab walk and
that crab walk. That's it. Yeah.
Yes.
Yeah. Isn't
Very,
that weird?
very cool. Yeah. Oh yeah.
I'd love that. So here we go. As the rover drives across the lunar surface, Viper will use the neutron spectrometer system to indirectly detect potential water present in the soil up to 3 feet below the surface for further investigation. And where the neutron spectrometer system finds a promising concentration of hydrogen underground, which means potentially ice, the rover will deploy its 1 meter drill, that's about 3 feet 4 inches long, to extract an ice sample to test. So, what is a neutron spectrometer? Believe me, this is above my brain pay grade, way over my head, as I said in the notes here. But this is an instrument used to determine the energies of neutrons and the relative intensity of neutrons of different energies in a neutron beam. Okay, sure. I've given a reference here if you want to dig more into this, but yeah, that sentence almost sounds like a pretzel logic kind of a looping. Okay, but anyway, pretty cool. If it finds this, it can drill down, take a sample, check it out. And this is pre-occupation, pre-moon base exploration to see if we can get a viable, sustainable conveyor belt of water supply, so to speak. And then that will determine, I'm sure, where the moon base is going to be put in terms of proximity, and then harvesting this ice and processing it and storing it. Those are all issues that would have to be dealt with as well.
Right. Yeah. And this reminds me of an article that, we probably wouldn't cover on the show, but it's very, very relevant. This just came out like 3 days ago on CNN that parts of the moon may provide a stable temperature for humans. And Ralph, this was some of the craters on the moon, because on the surface, direct sunlight, very, very to little to no atmosphere, very hot in direct sunlight. And then in the crater, like in on the dark side of the moon, well below freezing, negative 100, 200, whatever it may be. Some of the craters, though, are found to be around 63 degrees Fahrenheit if you get in just the right spot in the crater. So you can imagine that, if you're looking for moon bases, build your moon base in the shadow of a crater, and hey, it's a pretty nice 63 degrees, and make it toward, it sounds like maybe make it towards the South Pole. Hey, maybe you'll have access to some ice and some water. All these little research and advancements get us closer to a permanent settlement on the moon.
Yeah. And a little side note here for a second. I simply marvel at how water is out there. Remember, we did the story about the exoplanet that the James Webb Telescope, 1,150 light years away, they've determined that there was water vapor in the atmosphere of this thing. Water's out there. It's just so weird. I don't know. For some reason, it blows my mind to think that water is out there.
Right. It is the next thing to actually finding like methane, that life would produce or something like that. It is the next thing to realize that we're not the only ones in the universe, which would be, we can all assume, we can all run the numbers and say, it's pretty unlikely that we're the only ones out there, but to actually get definitive answers, that's something that we're all waiting for. And hey, Ralph, I'm looking forward to next week where maybe you announce just that. Maybe, who knows? But with that being said, everyone, this was a very fun segment. We hope you enjoyed it. And of course, if you want to find out more, computeramerica.com will have the show notes. And of course, we'll also have Ralph's website. You can just type in Ralph Bond Wicks, as I'm doing right now. And there you can find the tech reporter and of course, Computer America correspondent for KEX 1190 AM Portland, Oregon. So everyone, we'll have a link to this website. We'll have a link to everything, to all the stories, articles, videos. Ralph, thank you so much for being on the program. Catch you here next time. Everyone else out there, have a great weekend. Do something fun. Bye, everyone.